Hi guys, welcome back. Thermochemistry and thermodynamics, you guessed it. We've been talking about energy all the time. We've talked about the different kinds of energy, the different qualities of energy, heat and work. But we've got to measure the guy at some point. So whenever we measure things, we need units. So let's have a look at the units of energy. Well, there's many unit systems, but generally, except for the US, most people have converged on the System International, invented by those pesky French. And the unit for energy in that system is the joule, named after James Joule, who did some of the earliest experiments on heat. Now, what is a joule? It's very simple to define. Basically, if you have a force of 1 Newton, I won't explain what 1 Newton is, but it's a certain amount of force, and if that force gets, if it pushes something a distance of 1 meter, the object that is being pushed gains 1 joule of energy. Okay, now, so that's what a joule is. Now, in the case of heat, it's a bit hard to imagine 1 joule of heat. What exactly are you pushing when you heat something up? Well, you are actually pushing things. You're pushing the little gas molecules in the gas, and those molecules go faster, and as I told you before, when things go faster, the temperature goes up. So temperature is a measure of energy, and when you heat something up, you are pushing the gas molecules in a very strange sort of way and heating them up. A joule, 1 Newton times 1 meter. If you want to write a joule in its units proper, it would be N times M. N is the unit for Newton, M is the unit for meter. All right, another unit which is older, which is generally not used very much, but still pretty convenient, is the calorie. And this is the unit that James Joule was using in his time, and it's still used to measure things like the amount of energy in a chocolate bar, for instance, sometimes in America. So 1 calorie is the energy required to heat 1 gram of water up by 1 degree Celsius. Very simple to remember. So that's probably a more meaningful unit for you to get your head around. Just heat it up. 1 gram of water by 1 degree Celsius. That's actually quite a lot of energy, because water is a substance with a high heat capacity. We'll look at that in a second later. Now, in case you're getting scared, one food calorie is different to a chemical calorie. 1 food calorie is actually 1,000 calories. It's a kilocalorie. So if you see calories and you add them up on the chocolate bar and you're out by a factor of 1,000, you know why. The unit has been scaled. What's the relationship between the two? 1 calorie is 4.184 joules. Look guys, you don't have to memorize that. That will be given to you, but it's just one of those numbers that you, I don't know, sticks in your head after a while. 4.184 joules. Okay, so that's how we measure the units of energy, but how do we actually do it? How do we measure temperature changes and the energy that goes with that? Well, that's the process called calorimetry. Obviously, when you heat something, the temperature rises. And depending on how fast the temperature rises, we get something called the specific heat capacity, given the symbol big C. So what is it? There's an equation for it, you guessed it. C is the heat added to the system, divided by the mass of the system, divided by the temperature change, which is obtained when you add that amount of heat. So if the temperature change is very small, you have a very high heat capacity. So if you add a lot of heat and the system doesn't change temperature by very much, you have a big number divided by a small temperature change. That would be a very big heat capacity. If you have something with a low heat capacity, then you would add a very small amount of heat and get a very large temperature change. So the heat capacity is actually smaller in that case. All of that, and this is the mass heat capacity. There are other kinds of heat capacity as well. For example, the molar heat capacity. In that case, you, instead of dividing by the mass in grams, you would divide by the mass of 1 mole of the substance. But it's more common to use the mass heat capacity because, well, you can weigh things. So for instance, if you're building a house with a certain amount of brick and you want to know how much heat that's going to take to heat the brick up, its thermal mass, it's kind of nice to know what the heat capacity is in terms of the mass of the brick. So you can easily use this equation here to work out the heat capacity of water in calories. It's 1 calorie per gram per degree Celsius, or degree Kelvin. Kelvin and Celsius are the same. That's it, guys. Heat capacity in a few minutes. See you later.